A very good morning to all of you. Am I clearly audible and visible to you? Yeah. So I welcome you all to the start of this session in which this series, in fact, here is the bridge course for all of you. Whosoever is targeting NEET 2026 examination, without waiting too much for the results, if you have already appeared NEET 2025 or even if you are enjoying these holidays, I think this is the right time at which we can start our preparation in a much effective way towards our goal of NEET 2026. So as you all know that in this bridge course, you will be having 2 physics and 2 chemistry sessions track-wise. One physics and chemistry session in the morning time and one will be in the afternoon or evening time. There will be. Okay. So stay connected. You are going to have a lot of new things, a lot of interesting things to learn. And also we will try to emphasize on the crucial aspect and whatever the things which you might have missed for your preparation previously. And those are the things which we are really going to inculcate in this journey. Okay, so let us start, and with our journey going ahead, we'll keep talking about what could be the better methodologies of preparing for the exam. But today here I'm starting with a topic of kinematics, a topic of motion for all of us. This topic is called Galileo's formula. As we all know, we know this topic by Galileo's formula for motion under gravity. So we'll be learning that what are the important things, what are the problem solving strategies which are inspired or which basically use the Galileo's formula in physics problems. But before we talk about the Galileo's formula further, I would like to mention a point. That point is, as far as this topic is concerned, we study this in motion under gravity, in motion in a straight line. But today only I'm going to tell you that this is not only applicable only for motion under gravity or motion in a straight line, but can also be applied very beautifully for few problems of motion in 2D or projectile motion. Okay, and also can be applied in horizontal motion also if certain set of conditions are satisfied. And isn't it the beauty of physics that there are limited number of concepts, there are limited number of formula to be used, but their usage is not limited. Okay, so let us start. So what Galileo said, first of all, we'll try to understand that what is the formula, what are the concepts involved in motion under gravity. So we'll first study the Galileo's point of view. Then we are going to study my point of view, that how I actually apply this concept beautifully in some crucial problem models of physics also. Okay. So the first thing is, before developing our understanding towards the Galileo's formula, first of all, we have to develop our understanding towards the motion under gravity, referring to which Galileo initially gave his formula. Okay. So what is that? So if I particularly talk about motion under gravity, then we all have to understand that this is a type of uniformly accelerated motion. Uniformly accelerated motion. What is uniformly accelerated motion? First of all, motion, there must be some acceleration. That is, the acceleration vector for our discussion today is going to be non-zero. The acceleration is non-zero. There must be some acceleration, and this acceleration is going to be a constant. Calling a vector to be constant means its magnitude must also be constant as well as its direction must also be constant. I repeat, calling a vector to be constant. What are vector physical quantities? Vector physical quantities are those which do have a magnitude as well as they do have a direction. Okay, so calling a vector to be constant strictly implies its magnitude must also be constant as well as its direction must also be constant, just like gravity. That is, here particularly we would say that our acceleration vector is going to be minus g. What does this minus signify here? The minus is signifying always downwards. Always downwards. Okay. So the convention we are going to take for our discussion ahead, the convention which we are going to set as a rule is in x-axis and in y-axis. I'll tell you separately. In x-axis, we will consider all the forward vectors as positive and all the backward vectors as negative. Similarly, in y-axis, we will take all the upward vectors as positive and all the downward vector physical quantities as negative. All right. So, according to the convention in the y-axis right now, what we can say is, since gravity is always directed downwards, hence we can call the acceleration due to gravity is minus, okay, minus g. Near the surface of Earth or on the surface of Earth, the magnitude of acceleration due to gravity is also constant. Sir, is it going to be always constant at every point on the Earth's surface or even at a height or depth? No, it's not necessary. But that variation in the value of acceleration due to gravity, we will deal in the unit of gravitation. Today, our discussion is motion or kinematics. So during our kinematics problems, we all can assume that acceleration due to gravity is constant. Is that understood? It is a constant vector, magnitude is also fixed, direction is also fixed. And since acceleration is constant, the nature of motion is uniformly accelerated motion. In fact, in a while, we are going to learn that whatever Galileo said specially for this motion under gravity, if the same set of conditions of Galileo's formula are applicable for horizontal motion, then we can also use Galileo's formula as a beautiful technique for our discussion in horizontal motion. Is that clear? Right. Yes. Hi, everyone. Right. So I'll interact with you for sure and I'll answer all of your doubts. Let me take the topic a bit ahead so that you will be definitely having some crucial doubts and some doubts which I would like to entertain. Remember always, your doubt as a student is not only we believe that it is not only helping you. We would definitely love to answer your doubt, assuming that it is going to help out a lot of other friends. Okay, so this is just the introductory part of motion under gravity, why we call it uniformly accelerated motion, and what is the basic meaning of uniformly accelerated motion. All right, now, if I talk about the general equations which we use for uniformly accelerated motion, general equations for uniformly accelerated motion, this category, I would say. We all know these general equations. There is nothing new here. In this general equation thing, the first general equation we all know is V vector is equal to U vector plus A vector into T. Similarly, S is equal to ut plus half AD square. That is the second equation. So S vector equals to U vector into T plus half A vector into T square. And the third one is V square is equal to U square plus twice of A dot S. Okay. If you are noticing it appropriately, you will realize that all these equations are vector equations. See, I am every time writing the vector sign over the parameters, which means the equations are vector equations. Now, what are vector equations, sir? Vector equations, you can normally treat them as equations in which the physical quantities are to be substituted along with their plus minus sign. All the vector quantities are to be substituted here along with plus minus sign as per the convention. So, right now we are restricting our discussion to motion in a straight line. That's why I'm saying that put the values along with plus minus sign. In x-axis, forward positive, backward negative. In y-axis, upward positive and downward negative. Alright? But later on in our discussion, when we are talking about motion in 2D, when we are talking about motion in a plane, the same vector quantities must be substituted in component form. Means I cap or I cap and j cap like that. Alright? So remember, dear, that these set of equations are vector equations. Now, how we are going to use these set of equations, especially in motion under gravity, In motion under gravity, every time their acceleration vector can be irrespective of the fact that whether the body is moving up or the body is moving down or the body has stopped at the maximum height. I repeat, irrespective of the fact that whether the body is moving up or the body is moving down or the body has just stopped at the maximum height, it doesn't matter. Gravity will always be acting downwards. Acceleration due to gravity must be acting in negative direction. Many of us actually get confused that no sir, earlier in our previous classes we have learned that if the body is moving up, gravity is down, opposite, we should be taking it as negative. If the body is moving down, gravity is still down, supportive, we should be taking gravity as positive. No. First of all, forget these things of support and opposition. Okay? Don't get stuck with whether the motion is supported or the motion is opposing. No. If you really want to solve all the motion, all the kinematics questions, I really know that people start actual physics from kinematics and they keep struggling with the kinematics problems the most by the end of our preparation for the exam. Okay? So, since I don't want you people to struggle, I am telling you, try to follow the rules from day one. So, what is the first rule I am telling you to follow today here? That all these equations which you are going to use in kinematics are vector equations. Okay? So, stick with the vector convention. All the substitutions you are going to do are always as per the plus minus sign, as per the convention, not as per the support or opposition of motion. So, concluding this, that what you can say here, if I want to write these equations again, I'll write here as v vector is equal to u vector plus minus g into t. Similarly, s vector is equal to u vector into t plus half minus g into t square. It's nothing but s equal to ut plus half a t square. And you'll write v square is equal to u square plus 2a dot s. So here you can write down as 2 into minus g into s. Why you are not putting the sign of s vector, u vector and v vector, sir? Because that will depend on question. That will depend on whether the body is moving up, body is moving down. So velocities depending upon the nature of direction of motion. Displacement depending upon the final position. Okay, so I'll write it here also. Acceleration vector is always minus g, constant. Apart from this, for velocity vector, you will say if the body is moving up, where the body is, it doesn't matter. If the body is moving up, velocity vector must be considered as positive. And if the body is moving down, velocity vector must be considered as negative. So for velocity vector, we will consider the direction of motion. Okay. Acceleration vector always minus g, sir. Velocity vector, we will consider the direction of motion. Okay. And if we talk about the displacement vector, remember, rule 1, that all these equations are vector equations. Rule 2 is acceleration vector is always minus g. Velocity vector will depend on where the body is moving, direction of motion. Okay. If the body is moving up, from below my level it is moving up, or in front of my eyes it is moving up, or on the top of my head it is moving up. It doesn't matter where the ball is. It matters that the ball is moving up, and up. In all such cases, velocity must be taken as positive. Similarly, if the ball is moving down, above my level it is moving down, in front of my eyes it is moving down, or below my level it is moving down. In all such cases, we must be considering it as negative. For s vector, we have to consider the final position of body, final position of object or body. Okay, what does it mean? It means if this is my reference level, suppose this is the I, this is the reference level, okay? So reference is not necessarily always to be ground. Reference is, suppose you start your consideration of motion from this initial level, all right? Now, if the particle is above this level, doing what, sir? Whether it is moving up or it is moving down or it is stopped, it doesn't matter. For acceleration, it is always minus g, nothing matters. For velocity, direction of motion matters, position doesn't matter. For displacement, final position matters, direction of motion up or down doesn't matter. Okay, have a clear-cut idea. Once and final time, we will all repeat it again. I know you are connected by an online mode, but definitely we can all try to repeat it in our minds. Okay, rule number 1, all those equations are vector equations. Rule number 2, for vector equations, we have to consider the 3 vectors, no? Acceleration vector, velocity vector, and displacement vector. Acceleration vector is always minus g for motion under gravity, no matter what. Okay, no matter what. Where the body is moving doesn't matter to us for acceleration. Where the body is, above, in front, or below, doesn't matter. For acceleration vector, it is always minus g. Say it is minus g, no matter what. Okay. For velocity vector, where the body is moving, that matters. Upward or downward, positive and negative. Where the body is doesn't matter. Position doesn't matter for velocity. What matters is direction of motion. And for displacement, direction of motion doesn't matter. What matters is position with respect to initial reference level. So if the body is here, you will say its displacement can be taken as positive. If the body is here, going up or going down or maybe stopped, its displacement can be taken as 0. And if the body is here, going up or going down or maybe stopped, its displacement is taken as negative. Understood? So for acceleration due to gravity, it is always downwards, negative. For velocity, direction of motion matters. And what doesn't matter? Position doesn't matter. For displacement vector, position, final position matters with respect to initial. And what doesn't matter? Direction of motion doesn't matter. I hope that's clear to you. All the notes will be shared on the Telegram group and in the description of the video later on. But meanwhile, I would suggest you to take a screenshot. I hope the introduction of the motion under gravity is clear to you. In order to feel it, you know, I always say that mathematics stops after deriving the result, after getting a final answer. But physics starts after getting a result. It starts with the interpretation of the formula. It starts with the analysis of the examples dealing with the problems. Okay, right. Let us move ahead. So now this is all about what is motion under gravity. Let us try to understand Galileo's point of view, what Galileo said. Then we will also talk about my point of view. All right. So Formula 1, Galileo actually gave 2 important expressions or 2 important patterns regarding motion under gravity. Okay. So first of all, before I talk about the patterns, what I want you to understand is that if there is a ball, which I am going to release, try to feel it, huh? Mass m. Why you are writing mass, sir? Does it really matter to us? I would say no, it doesn't matter to us. The reason it doesn't matter to us is that equations of kinematics are mass independent. So the mass actually doesn't matter till the time you don't encounter air friction. Okay, so in our today's discussion, we will not talk about air drag. After a few days, we will take up the same illustrations and we will see what if the air friction is taken into account. All right. So here it's a mass m. Initial velocity is 0. Okay, that means it is released. Okay, and it is falling down. So if it is released and it is falling down under the influence of gravity, acceleration vector's magnitude is g, constant. Why you are not writing minus g, sir? Because I am writing here as magnitude. Minus was only telling the direction downwards, which we have already taken into account. All right. So acceleration vector's magnitude is g, constantly acting downwards. So just feel it that there is a ball which you are constantly pulling down. Okay. Right now, the gravity is responsible to pull it down. But the same feeling I want to induce in your mind, the reason is we are going to apply the same important concepts in horizontal motion. Okay. So imagine that there is a ball or there is a box which you are constantly pulling towards yourself. If you are constantly pulling it towards yourself, with the passage of time, it will keep on getting faster or slower? Definitely faster, faster and faster and faster. In that case, if I ask you that in t0 time, it travels some distance. Now it became faster. So next t0 time, it will travel somewhat greater distance. Now it has become much faster. So in next t0 time, it will be traveling a lot of distances. All right. What I'm saying is the ball gets faster. The ball becomes faster and faster and faster. So obviously in equal time intervals, there will be greater and greater distances traveled. Its mathematical analysis was done by Galileo. By feeling is, this situation can be felt, I believe, by all of us. Yeah, but definitely its mathematical part was given by Galileo. So just a moment more, then I'll read your comments and I'll be asking you, answering your doubts also. But before that, let us talk about the Galileo's first formula. So the first formula given by Galileo was ratio of distances traveled in equal time intervals. So as we have understood the situation that in the influence of gravity, when you release a body, the body keeps on getting faster and faster and faster. So the ratio of distances traveled in equal time intervals, I would say, must be increasing. Must be increasing. All right, because the body keeps on getting faster. So in the equal time intervals and irrespective of exact duration. What do you mean by that, sir? I mean by that is that the time duration must be equal. Now those equal time duration can be 1 seconds, 2 seconds, 5 minutes, any time. Okay. Interesting part is that the time duration must be equal. How much, sir? How many seconds? How many minutes, sir? It doesn't matter to us. All right. So irrespective of exact time duration, and the ratio must be increasing. And what Galileo said? Galileo said that this ratio is equal to, suppose I say that here the distance traveled in this interval is S1, the displacement covered in this interval is S2, and the displacement covered in this interval is S3. Then here I would say S1 ratio S2 ratio S3. That is given by 1 ratio 3 ratio 5 and so on. All right. This is also called as Galileo's law of odd numbers. Also called as Galileo's law of odd numbers. Okay. In four intervals, you will say 1, 3, 5, 7. In 5 intervals, 1, 3, 5, 7, 9. In 6 intervals, 1, 3, 5, 7, 9, 11. You just have to keep counting the odd numbers. Am I clear with this? Okay. And 2 more points. This can also be applied. In horizontal motion, which I am emphasizing, can also be applied in case of horizontal motion, provided. So what matters, sir? What matters is the nature of motion. If the nature of motion is same in y-axis and x-axis, if the nature of motion is same or the variation of parameter is same in vertical direction and in horizontal direction, then by mathematical equations, their conclusions are also going to be same, no? Which means, for example, here Galileo talked about initial velocity 0 in the influence of gravity. Can't I say that even in the case of horizontal motion, if initial velocity vector is 0 and acceleration vector is a constant vector, if initial velocity is 0 and acceleration vector is a constant vector, then this Galileo's law of odd numbers, and even the Galileo actually, in our preparation we talk about two Galilean formula. One is in front of you, formula 1. Formula 2, we will talk in a while, today itself, don't worry. But formula 1, if I talk about, that is Galileo's law of odd numbers, that we can also apply in horizontal motion, provided initial velocity is 0 and acceleration vector must be a constant vector, right? So, and last and final tip, sir, we are always talking about a body that starts from rest and then keeps on getting constantly accelerated, and then these rules, the formula, the equations we have talked about. But sir, if we throw a ball like this in the absence of air friction, if air friction is not encountered, air drag is ignored, if we take a ball and throw it up, then ascent and descent, upward motion and downward motion are symmetric, isn't it? Time of ascent must be equal to time of descent, provided no air friction is taken into account. So can't we use the symmetry logic, sir, here in the same situation? Yes, dear, we can use, and that is the full and final formula from my side for Galileo's formula number 1. Then we will see some illustrations. Okay. So another thing, last thing, what I want you to keep it in mind is, you are talking for a body which has started from rest. What if the body is about to stop? Instead of acceleration, speeding up, it is retarding, speeding down and coming to rest finally. Can't we say something? We can. What we will say here is, if a body, suppose, if a body is about to stop in 3 seconds, then now if someone is asking you the displacement covered ratio, S1 ratio, S2 ratio, S3, then you will say that will be equal to, so if the body would have accelerated, speeding up, the ratio would be 1:3:5. But if the body is retarding and about to stop, the ratio will be inverse ratio. That will be 5:3:1. Isn't it? Let us take another example. If body is about to stop, in next 5 seconds, then you all try, tell me the ratio. Yeah. See, if the body has started from rest, the ratio will be 1:3:5:7:9. 1:3:5:7:9. If the body is starting from rest. But if the body is about to come at rest, the ratio will be inverse ratio here. That is S1 ratio S2 ratio S3 ratio S4 ratio S5. These are telling you the ratio of the displacement covered in first, second, third, fourth and fifth second. That will be, see, first of all, go for the direct ratio. It is 1:3:5:7:9. But here the body is about to stop. So the ratio will be reverse. 9:7:5:3:1. Is that clear? All right. Yes, very nice. Nagaraju, very nice. So now I can see your comments and I can help you out. Then we will quickly take the recap, whatever we have understood till now, and we will bombard the problems. Okay. Right. Very nice. Everyone is answering. This topic come under class 11th. Yes, this topic comes under class 11. This topic comes in kinematics, motion in a straight line. Starting of mechanics, I would love to say that it is the starting of mechanics, and more importantly, it is one of the topics, motion in a straight line. I hope you all would agree with that. Motion in a straight line is one of the most struggling topic in physics. We start with this, this comes after units and measurement. We start with this unit, and by the time we develop our mindset, by the time we start feeling the mechanics, this topic is, over. And then till the end of our preparation, we keep struggling with that. So here today, I have come to make you understand that always there are two ways or more than two ways of doing a very nice problem. If the problems are easy, I'll train you to do those problems orally, mentally. Okay. But if the problems are of complex nature, trust me, there would be more than two or more ways of doing those problems. So here in today's interaction, I would like to, show you some methodologies that, okay, these are the convention methods by which some standard PYQs of NEET and JEE are supposed to be dealt. But here in Sri Chaitanya, how we train people, how we train our kids to solve those conventional problems in much easier way. Sometimes a slight, higher notch of formula is required to solve a particular problem in an easy way. Sometimes your logical depth is required. So every chapter and every topic has a different quality or a different taste of asking the problem in the exam. If you understand the psychology of the chapter, then definitely it gets much easier to prepare the chapters. Okay, right. Any other doubts to anyone? You can just put your doubts in the comment section. I'll be answering them. All right. So let's take a quick recap. I hope everyone is sorted till here. What we have learned today that first of all, we started our discussion with fundamentals of motion under gravity. Motion under gravity, a quick recap we are taking. Okay. Motion under gravity is a uniformly accelerated motion. The meaning of uniformly accelerated motion is acceleration is constant. Keeping a vector constant means its magnitude is also constant as well as its direction is also constant. All right. The equations of motion which you have been, dealing with since your childhood, I would say 9th, 10th class, those equations are actually the vector equations. Vector equations means when you substitute the value of initial velocity, final velocity, acceleration and displacement vectors, those must be according to the convention. In motion in 1D, we will stick to the convention that in y-axis or while dealing with the vertical motion, upward vectors we will take as positive, downward negative. Similarly, going forward in x-axis, forward vectors we will take it as positive and backward vectors as negative. All right. Then the sign of acceleration in the motion under gravity is fixed. Acceleration vector is fixed, minus g. But for the velocity vector, you have to consider the direction of motion and not the position. But for displacement vector, you have to consider the position and not the direction of motion. Then what we have learned is, we have learned the Galileo's formula for motion under gravity. Galileo gave this formula for the situation in which initial velocity is 0, and understanding the fact that the acceleration is also constant in motion under gravity, I have given you my opinion, that opinion number 1 or technique number 1, what I am trying to make you understand is that the Galileo's formula or Galileo's law of odd numbers we are also going to apply in the case of horizontal motion, provided our initial velocity is 0 and acceleration vector is constant even in the case of horizontal motion. Also, since we know that motion under gravity, throwing a ball up like vertical projectile and coming it down, ascent and descent are symmetric. So the second opinion from my side and the concluding opinion is, if the body is starting from rest, the odd numbers ratio is valid in the forward order 1, 3, 5, 7, 9, 11. But if the body is about to come at rest, that too under the influence of constant retardation, assuming constant retardation, then the odd numbers ratio will be exactly in the reverse fashion. Instead of 1, 3, 5, 7, 9, it should be 9, 7, 5, 3, 1, like that, assuming constant retardation. Okay, so I always see the ratio in the forward order. then I do its reverse. I hope that's clear to you. All right, if you want, you can take the screenshot. Right. Sir, could you tell some basic of physics, sir? Yes, Sangeeta ji, here the basics only is going on today. Okay, I'm writing everything in words, everything in the diagram, so you can feel it, you can remember it, and now it is the time to implement it. Let us start with some example. So a freely falling body means initial velocity is 0 and it is falling under the influence of gravity. Travels what percentage of total distance in the 5th second? In the 5th second, what percentage of the total distance the body travels? That is the question. Okay, so let us see. Can I say freely falling? For free fall, I am assuming that here initial velocity 0 and acceleration vector is constant. Okay, that's valid for free fall. And in that case, by Galileo's law of odd numbers, the displacements covered must be in the ratio S1 like S2, S3, S4, S5. Let us stop till S5. Why do stop at S5? Because you are interested in 5th second only. So can I say the first distance is, suppose, X. The first distance covered is X in the 1st second. Second, it must be 3X, odd numbers. Next it must be, yes, 5X. Next it should be 7X. And next it should be 9X. Okay, 1, 3, 5, 7, 9. And what will be S total? In 5 seconds, what will be S total in 5 seconds? If we are assuming that our journey is only till 5 seconds as per the language of the problem, that is going to be, add them up, 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16, and 16 plus 9, 25. So it is 25x. So if they are asking you the percentage in the 5th second. So percentage in the 5th second is, how do we calculate the fraction? Favorable case by total number of case. And how do we calculate the percentage? Favorable case by total number of case into 100. So that will be 9x by 25x into 100. 9x by 25x into 100. Okay. So what you can see here, see, x and x will be cancelled. 100 will be cancelled by 25 at 4 times. 9 into 4, it is 36%. 36%. Is that clear? All right. In fact, I would say in the same problem, in same situation, if they are asking you what are the percentage journey travel in each second in first 5 seconds, which means if they are talking about S1, S2, S3, S4 and S5. All right. So what I want you to understand is, if they are asking you percentage journey covered in the same problem. Understood? Here they have asked you only one problem. We have answered it. Answer is 36%. But I am saying that suppose they ask you exactly percentage journey covered, then what you will do? So do you realize that here every time you will have to do the favorable case which will keep on changing for every interval. Total number of case will be every time 25x into 100 for first 5 seconds. When you add them up, it is always 25. So 100 will be cancelled by 25 at 4 times. 4 into 9 you did. You got 36%. Okay. Previous to it, it was 7 here. So instead of getting multiplied with 9, it will be getting multiplied with 7. So 7 into 4, you will get 28%. Previous to it, it will be 5. Remember, 100 by 25 is 4. So 5 into 4 will be 20%. Previous to it, it is 3. 3 into 4, it is 12%. Previous to it, it is 1. 1 into 4, that is 1%. So you can check the total 100% of the journey. See, 1 into 4, it is 4% here. 4%. So let me make your calculations a bit simpler. 36 plus 4. 36 plus 4 will be 40. 28 plus 12 will be 40 again and remaining 20. So 40 plus 40 plus 20. See, you got 100%. I hope the logic is clear. Sir, why this is 25 every time? It is total. Because total is coming 25 because it is fifth second. For fourth second, it will be something different. For sixth second, it will be something different. But the way of calculating the percentage in final interval or in any of those intervals, that way is going to be exactly same. I hope that's clear. Everyone is understanding in the comment section. Let me know. Give me a thumbs up if you understand everything, or if you have a doubt, just put it over there. I believe that any of you will have any doubt. I would love to answer that because that might be helping our other friends who are still connected and learning. Tell me, do you have any doubts? No. I hope everyone has understood that. Okay. Let me take you towards another one. Yeah. So a stone falls freely. That's already a NEET PYQ. A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, the next 5 seconds and the next 5 seconds. As I said, exact duration doesn't matter. First 5 seconds, next 5 seconds and the next 5 seconds. Irrespective of exact duration, if time intervals are equal, then what we can say here? Irrespective of exact duration, if time intervals are equal, in that case, and they are equal, right? 5 second, 5 second, 5 second. They were actually 5 seconds time interval or 2 minutes time interval. It doesn't matter here. Then in that case, h1 ratio h2 ratio h3, that will be given by 1 ratio 3 ratio 5. 1 ratio 3 ratio 5, like that. Okay. Or I can also say that h2. So h1 I will say h1 by h2 will be equal to 1 by 3. That is h1 is equal to h2 by 3. And similarly h1 by h3 is equal to 1 by 5, or you can say h1 will be equal to h3 by 5. All right. So the correct option should be h1 is equal to h2 by 3, h1 is equal to h2 by 3 and same that is equal to h3 by 5. So see, correct option is option D. It's very simple question. Why I have taken it today here is because I want to re-emphasize on the point that exact duration doesn't matter. What matters is that initial velocity must be 0, number 1. Acceleration must be constant, number 2. And number 3, time intervals must be equal. Of what duration? Doesn't matter. All right. Now, let me take you towards Galileo's formula number 2. Galileo's formula number 2. One thing we have already understood, that if you release a ball, the body will keep on getting faster and faster and faster. Can you feel it? That the body will keep on getting faster and faster. So in the same time interval, it will keep on traveling greater and greater and greater distance. So I'll write the situation once again. I'll portray the situation once again here. Mass doesn't matter. Released means initial velocity is 0. It is actually released, and the acceleration vector is constant, minus g, that's constant. Then definitely with the passage of time, the body keeps on getting faster. Okay. Speed keeps on increasing. Speed keeps on increasing. All right. This is the situation. Now, if the body keeps on getting faster and faster, can I conclude that if you want to see that how much time it travels to cover a distance of x0, x0 is the distance. Previously, what did we fix? We fixed the time. So in the same time, the body will keep on traveling more and more and more distance. Right now, what we are trying to fix? We are trying to fix the distances. So in the distances, so can I say, since the body keeps on getting faster, if it takes time t1 here, takes time t2 here and takes time t3 here, the body initially was the slowest. So it will take the largest time, maximum time to cover the same distance. And as the body keeps on getting faster and faster and faster, for the same distance, it will be traveling the same distance in a much lesser time. The body keeps on getting faster. So in the same time, it will keep on traveling greater and greater and greater distance. But for the same distance to be traveled, the time taken must be less, which means it was slowest here. So the time will be maximum. Here it is fastest, so time will be minimum. So here I can simply conclude that T1 maximum time, then T2, then T3 and so on. Okay, the time will keep on getting reduced. So Galileo's second ratio or second formula is ratio of time taken to travel equal distance intervals. Ratio of time taken to travel equal distance intervals, as we have understood, it must be decreasing. It must be decreasing. All right. Distances traveled in equal time interval must be increasing. Time taken for equal distance interval must be decreasing. I hope you can feel that. Now let us repeat it together. You are connected in online mode right now, so you just repeat it in your mind and heart, but repeat it honestly, right? So that there is no confusion in the language of the properties or ratio. Ratio of distances traveled in equal time interval must be increasing. Ratio of time taken for equal distance intervals must be decreasing. Body is getting faster. Body is getting faster. So in equal time interval, it will keep on traveling more and more and more. Body is getting faster. So to travel a particular distance, it will need lesser and lesser and lesser time. I hope that's sorted out for you. Okay. So that ratio is actually given by root 1 minus root 0. I mean, if I just try to take the ratio of T1 ratio T2 ratio T3 ratio T4, so the pattern is going to be root 1 minus root 0, which is nothing but 1, ratio root 2 minus root 1, ratio root 3 minus root 2, ratio root 4 minus root 3, like that. Okay, understood? So how to compare the magnitude? I mean, in 1, 3, 5, 7, it's clearly visible it was increasing, Galileo's law of odd numbers. But here if you try to see, its value here is 1. Its value here is 1, okay? And here its value 1.414 minus 1. Its value is approximately 0.414, okay? Here its value is 1.732 minus 1.414. So you can see it is decreasing ratio. All right. So in Galileo's law of odd numbers, it will be increasing ratio if the body is accelerated from rest. If it is retarded to rest, finally it is stopping, it is also again decreasing ratio. 7, 5, 3, 1. That's what we have understood. Here, this is a separate story. In the same situation, in order to travel equal distances, the time required must keep on getting lesser and lesser and lesser. All right. If you want, you can take the screenshot. All right. Now, let me take you towards some interesting problems and the conventional way of doing those problems. Few examples which we have already seen, but now we will compare how to do the problems in a conventional way or by using equation, what generally people will do. And how we will do that after today's session, we will also try to see that. Okay, so the first problem is, what will be the ratio of the distances moved by a freely falling body? Freely falling body, initial velocity 0, acceleration vector is constant. Galileo's formula can be applied. From rest in 4th and 5th second of the journey. So the conventional way of doing that is, general way or common way of doing that is, formula of distance traveled in nth second, or more appropriately displacement covered in nth second. So first issue with the student is, sir, we don't even use this formula very oftenly. Okay, we don't even use this formula very oftenly. So that's why, and I even didn't give you today this formula because this is sometimes also called by the people as fourth equation of motion. Okay, I'm very neutral towards this formula. I don't have a biasing. I don't like it too much. I don't dislike the formula. If it is needed, sometimes I may use the formula. But today I'm going to tell you alternative, easier ways of doing the same question. But before that, how generally examiner is expecting you to do this problem is distance traveled in nth second, because they are talking about fourth second. They are not talking about 4 seconds. They are talking about fourth second or fifth second. So that's why distance traveled in nth second. The formula is u plus a by 2, 2 into n minus 1. Okay, this is the formula. So here, what they are asking you is distance traveled in fourth by distance traveled in fifth second. Okay, so that will be, and that's freely falling. Freely falling means you can say here that initial velocity is 0 and acceleration vector is minus g. Okay, initial velocity is 0 and acceleration vector is minus g. So if I fit in this formula, it will be 0 plus minus g by 2, and it is 2 into 4 minus 1, and it is 0 plus again minus g by 2, and it is 2 into 5 minus 1. All right. So as you can see, 0 and 0 is anyways can be ignored. This minus g by 2 and minus g by 2 can be cancelled. So what you will be having is 2 into 4 minus 1 by 2 into 5 minus 1. So that will be equal to 4 into 2, 8 minus 1. That's 7 by 5 into 2, 10 minus 1. That's 9. So the ratio is 7 by 9. Ratio is 7 by 9. Everyone got the answer? Everyone got the answer? Yes. Adi Lakshmi already answered that. Very nice. Few other friends have also answered that. It is 7:9. Okay. This is the general way of doing that. But let us talk about the same problem in a much easier way. That is Galileo's formula for today. All right. If you want, you can keep a record of this. Notes will also be shared. Don't worry. Right. Again, the same problem, but our way of doing that. Our way. Our way is Galileo's formula way. Why you can apply the Galileo's formula here, sir? Because it is a freely falling body. U0, a constant. Anyways, Galileo talked about the freely falling situation directly. So if they say fourth second and fifth second, they talk about fourth second and fifth second. So let me write this directly in front of you, that if I write S1 ratio S2, I mean S1, S2, S3, S4 and S5. So S1, if it is X, suppose, okay, everyone can tell me S2 it will be 3x, S3 5x, S4 7x, S5 9x, and what they are asking you is the ratio of fourth and fifth second journey. So fourth and fifth second of the journey. So if you take its ratio, answer is directly 7/9. It is again 7/9, isn't it? So why it is easy and why it is advisable to use Galileo's formula? Number one, you don't have to take the pressure of remembering this big formula. Number two, even if you remember the formula, then you have to think about the substitution of the values. In examination pressure, sometimes you may replace plus minus that way. Sometimes you may do some error during the substitution. There is a possibility. I'm not saying you will do the error. I'm saying there is a possibility of the error. And the way you are good with the numericals in your classroom practice or while listening to this lecture, it's not going to be the same way of your efficiency during the exam. During the exam, definitely there is a lot of pressure here. In that case, always try to use logical approaches in physics rather than too many mugging up the formula and all. Okay, so no too many formula, but logic. Formula or logic? Logic. Okay, that's the beauty of physics. Let me take you towards another one. Now, now I have taken this position, this problem again to re-emphasize on the on this thing, that the same Galileo's pattern can also be applied in case of horizontal motion. So a particle starts its motion from rest under the action of a constant force. What is this assuring here? Constant force. Constant force means acceleration will also be constant. Means acceleration will also be constant. Okay? And from rest means initial velocity is 0. So they are nowhere saying motion under gravity. Nowhere they are mentioning motion under gravity. But you as an aspirant, you as a physics student have to understand that from rest means initial velocity 0, constant force means constant acceleration there will be in the object. If both the situations are satisfied, then definitely we can apply the Galileo's pattern. So I don't know what the exact problem is, but what I know is the problem can be solved by Galileo's formula. All right. So the question is, a particle starts its motion from rest under the action of a constant force if the distance covered in first 10 seconds and that covered in first 20 seconds. Starting from rest, okay, at t equals to 0, you're talking about first 10 seconds. So first 10 seconds, it travels a distance x, suppose. It travels a distance x. And now you talk about first 20 seconds. First 20 seconds means 10 seconds. And then in the next 10 seconds, definitely the body would have become faster. So in the next 10 seconds, so if this distance was x, then the next 10 seconds, its distance is 3x. According to the situation, what they are telling here, they are telling that it covers S1 distance in the first 10 seconds. S1 is equal to x. And they say in this interval, S2 in the first 20 seconds, S2 in the first 20 seconds means x plus 3x, that is equal to 4x. So what you can say? Clearly, see, S1 value is x and S2 value is 4x. So clearly S2 will be equal to 4S1. S2 will be equal to 4S1. Is that clear? Is that clear for us? All right. This is an easier way of doing it. That is, directly we can do it by Galileo's formula. But suppose, sir, we don't, the Galileo's formula, it's not striking in our head in the exam. If we don't want to do it by Galileo's formula, what is the general way or common way of doing this problem? The common way of doing this problem would have been, sir, it is starting from rest, initial velocity 0, constant force, constant acceleration. Okay. So I'll try to apply two times the equations of motion. So first of all, I would like to write it as S1 will be equal to ut plus half at square, 0 into 10 plus half, acceleration vector as some a naught into 10 ka square. What I am doing is I am applying the formula S equal to ut plus half at square. All right. So first is this. So what you can write here is 10 square is 100. 100 by 2 is 50. So you got it as 50 a naught. And similarly, S2 will be equal to 0 into 20 plus half a naught into 20 square. You can see 20 square is 400. 400 by 2 is 200. So what you got is 200 a naught. Clearly, if you write, you will get S1 by S2 is equal to 50 a naught by 200 a naught, or 1 by 4. This implies S2 will be equal to 4S1. S2 will be equal to 4S1. Okay. Once again, I am telling you here U is equal to 0 and A vector is equal to constant. All right. Is that all right? So any question can be solved by a number of ways, but today we are trying to understand the beauty of Galileo's formula and how to, skip the equation solving, formula remembering, and then doing it. Better to understand the pattern-based physics. In our journey forward, and for all the students who have, already taken my marathon lectures previously, and all those who know me, right? I always favor the logic over the formula. We always try to understand the pattern-based physics, the beauty of using the same type of formula in different topics and chapters of physics. I hope that is clearly understood by you. Someone is having the query that which chapter we will take up in the month of June. We'll go in a sequence here. There are two tracks going on. One physics and chemistry lecture you are having in the first half, that is in the morning time. One you are going to have in the second half, that is afternoon and evening. And in that case, one track we have started from, like I have started with you with mechanics. In the afternoon and evening session, Hari Mohan sir will start with you with electricity and magnetism part, basically electrostatics today. So stay connected. You are going to learn many important things, very beautiful things in that track also. All right. So both the things will keep going parallelly. Don't worry. Chaliye, let's move on to the next one. So this was the easier way, much easier way. We can just understand the Galileo's pattern and do the same problem. All right. Now, that's a NEET PYQ, one of the most common doubts of students, water tap model. So we will also try to understand the same problem by different approaches. Okay. Number one approach, what common people will do. Number two, how we can do it mentally or orally just by using Galileo's pattern. So what is the common way of doing it here? Common way, first of all. So why it is necessary to understand the common way also? Because sometimes when any of the initial condition of Galileo's formula is violated, means either it is not starting from rest, or acceleration throughout is not constant, or else the time intervals which you are talking about is not equal. So if the initial velocity is non-zero, or the acceleration varies, or the time interval is not equal, in all such cases, who will help you? The general equations of motion only help you. Okay, so you need to understand the conventional physics as well as the cute little techniques of using to be used to solve the critical problems. All right. So common way of doing it is, the water drop falls at regular intervals from a tap 5 meters above the ground. So let us try to understand it diagrammatically. So that's a tap, that's a water tap here, and you are just opening the nozzle of the tap, and water droplets are falling at regular intervals from 5 meters above the ground. This is 5 meters above the ground level. 5 meters above the ground level. All right. And what they are saying is the third drop is leaving the tap at the instant first touches the ground. So if this is the first drop, that is touching the ground, the third drop is leaving the tap, and obviously the drops are not coming out with some velocity, they are falling. Falling means you can say your initial velocity is taken to be 0, free fall. Okay, and obviously under the influence of gravity. So you have closed the tap. In fact, you haven't opened it. You have closed the tap. You don't want the tap water to come out, but suppose the tap is leaking. Okay, it is not coming out with some velocity, it is being leaked. So in the influence of gravity, it starts from rest and it starts falling down. The situation is, when first drop reaches the ground, the third drop leaves the tap. So definitely second drop will be somewhere here. The second drop will be somewhere here. Okay. And it falls at regular intervals. It is written at regular intervals, means time interval is also same. The delta t time is also same. Delta t or t naught. What is the exact duration, sir? It doesn't matter to us if we want to solve this question by Galileo's pattern. But here we would like to understand this. What is the conventional way of solving this problem? So I would like to see what is the total time of fall. First of all, I'd like to see what is the total time of fall. So time of fall will be given by under root of 2h by g. Under root of 2h by g. So that is under root of 2. The total height is 5 meters and the acceleration due to gravity I can take for the simplicity as 10, and hence what we are getting it is 1 second. 1 second. Then I would like to see what is the delta t time gap in any two drops. Between any two drops. Time gap, delta t, between any two drops. So if it is at regular interval, then definitely it is half, because there are two time gaps between them, two intervals. So half of time of fall. So what you are getting it as half seconds or 0.5 seconds. Half seconds or 0.5 seconds. Which means how much the second drop has fallen. How much the second drop has fallen. H fall for the second drop. So I will calculate this H fall for second drop. H fall for the second drop. So how much it is? Again, it is half gt square. S is equal to ut plus half at square. So 0 into half, which means half seconds, plus half gt square, 10 into half square. So what you are getting it is, first term is 0 and the second term is 10 by 8. 10 by 8 is 1.25 meter. 1.25 meter. So are they asking you in the question that how much the second drop has fallen? Let us read the question. How far above the ground is the second drop at that instant? Which means they are asking you the height of second drop. Height of second drop from ground. What they are asking you is height of second drop from ground. How far from the ground? How far from the ground the second drop is? See, what they are asking you here is this height of second drop from ground. So can I say the total is 5? Out of that 5, if you subtract this 1.25, you will get the final answer. So height of second drop from ground. Step by step process. Height of second drop from ground. How much is that equal to? That is equal to 5 minus how much it has fallen? 1.25. So the final answer is 3.75 meters. Mostly people do this mistake, and they did this, that I have already mentioned, it's a NEET PYQ. Most of the aspirants did this mistake that the moment they got the answer as 1.25, see, one of the option is 1.25 and examiner puts the 1.25 as option A. So most of the aspirants will be happy, they will simply tick mark and bubble it, but you need to read the question very, very carefully. They are not asking the height of fall, they are asking you the still remaining height above the ground. So that is 3.75 meter. Option C. Option C, very nice, 3.75 meter. And I hope the people who are answering, yes, notes will be surely shared. Notes will be shared, Saujanya. And I hope the remaining people, Nagraju, Prajit, DG, Reddy, whosoever is answering this, I believe that you are answering faster than me by using the technique taught by me, that is Galileo's formula. So indeed, this is a 3-4 step process, can be done nicely, but involving so many steps and such calculations in the exam is not every time advisable. Now let us see a relatively much easier technique, that is obviously Galileo's formula. And let us see how many seconds we will take to answer this question. Okay, so the same situation, 5 meter tap, that situation. So we have this tap which we are trying to close, but the tap is leaking in such a way that the water drop falls at regular intervals. In the situation, it is mentioned that when the first drop reaches the ground, the third leaves the tap. Total is 5 meter. Somewhere here, definitely there will be the second drop. Okay. So what is our way of doing that? What is our way of doing this question? So what we will do, we will say, suppose this is X, then definitely this will be 3X. Galileo's formula, yaar, 1:3:5:7. So it is 1:3, X and 3X. In that case, what you can say here, we will say X plus 3X will be equal to 5 meters, which means 4X is equal to 5 meters, which means X will be equal to 5 by 4, that is 1.25 meters. But what the examiner is asking you, this 3X. So 3X value is 3 into 1.25 meters, that is 3.75 meters. And hence the correct option is, and C. Is that clear? Very nicely portrayed situation, no? So as I said, it's a NEET PYQ. People have actually done this mistake, a lot of aspirants. Even when we want our students to, properly read the question, develop an ability, develop a habit of reading the question as well as options of the objective problem nicely, I always prefer to give this problem. And I know that what the majority of students will do the mistake in. They don't do mistake in physics. They do mistake in reading the problem. So guys, remember, it's a national level exam. the problems which you have done even on the last day and the problem which has come in the exam, these two problems might be similar but might not be the same. So even if you find some sort of familiarity in the exam, always develop a habit from day one, from today itself, to read the questions appropriately, to read the options carefully. And these type of set of options are a triggered mistake offered by the examiner. The examiner triggers the students to choose option A. Okay, right. I hope this methodology is also clear. Let us take another problem now. Now, a body falling from a high minaret travels 40 meters in the last 2 seconds of its fall to the ground. 40 meters have been traveled in the last 2 seconds. They are asking you the height of the minaret. The minaret means, in Hindi we also call it minar, I mean long buildings, you can say. The meaning of this term high minaret tower is long buildings. Okay, multi-story building, minar towers, like that. Okay. So 40 meters in the last 2 seconds and it is falling. Falling means, again, you can assume that initial velocity is 0. All right. So the situation I'm trying to mention here. So it's a, okay, let's make the shape of a cliff here. And this total is suppose 40 meters. No, total is H total they are asking, right? H they are asking, fine. And they are asking last 2 seconds 40 meters. 40 meters in the last 2 seconds. In last 2 seconds. All right. So here, from here to here, it will be H minus 40 naturally. H minus 40. They are asking you the value of H in the question. So the common way of doing this problem. Okay. Common way, like if we have to use the kinematics equation, what is the common way of doing this? So the problem comes in front of you. The first thought you get is that let us try to understand the last 2 seconds motion, because this is the portion of the motion about which we have the maximum information. All right. So here what is happening, that I would like to find out this velocity here. What is this velocity? And this velocity will be under root of 2g h minus 40. This velocity is going to be 2g h minus 40 because of this fall. Because of this fall, the ball is released from here, u equals to 0, and it has fallen h height, h minus 40 distance. So by under root of 2as or under root of 2g h of fall, you can get it as under root of 2g h minus 40. All right. Now let us try to understand this later part of the motion, means the last 2 seconds. In these last 2 seconds, I am going to apply s equal to ut plus half a t square. All right. Convention, it's a vector equation here. So I'll be putting everything, I'll be keeping everything with plus minus sign. So displacement is downwards 40 meters. So minus 40. Initial velocity for this interval is minus of under root of 2g 10 into h minus 40. Okay. And the time here is 2 seconds plus half into minus 10 into 2 square. If you want to solve it further, minus 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 can be cancelled from all 3 terms. See, this minus and this minus can be cancelled from all 3 terms. Here that's 40, and it is equal to, you'll get 2 under root of 20, and it is h minus 40, plus minus has been cancelled, and it is 2 square here, 1 2 will be cancelled, 2 into 10, 20. All right. Again, you can take this 20 on this side. So 40 minus 20 is 20. That is twice of under root 20 h minus 40. See, this 20 will be cancelled by 2 at 10 times. 10 will be equal to under root of 20 h minus 40. Then further what? Basic calculation, square both sides, 100. That will be 20 h minus 40. Now what you can do? 100 by 20, it is 5 h minus 40. And finally the h is coming out as 45 meters. Yes, we have taken a lot of steps. Yes, this is the common way of doing the same problem. That's a JEE mains PYQ. That's a JEE main previous year question. I have taken it to give you some more idea towards the technique which we are learning today. All right, this is the last problem of our session. I hope the exact solution, basic portion, breaking of the motion and further dealing with it is clear to you. All right, but now let me take another beautiful method of doing the same. So what they are telling is, in the last 2 seconds, you are covering how much? 40 meters. So let us see, let me try to write the displacement covered in first 1 second, then displacement covered in second, and the displacement covered in third second, the displacement covered in fourth second, the displacement covered in fifth second, like that. Okay, and then I will see what they are actually asking. So basically, I'm writing what is the displacement covered in first second. The displacement covered in first second by the formula is half AT square, half GT square. So G into 1, half into 10 into 1 square, that is equal to how much? 5 meter. Okay. The next will be 3 into 5 meters, so that is 15 meter. The next will be 5 into 5 meters, that is 25 meter. The next is 7 into 5 meters, that is 35 meters. The next is 9 into 5 meters, that is 45 meters. But now the question, in the question examiner is asking that they are travels 40 meter in the last 2 seconds. 40 meter in the last 2 seconds are these seconds. If you add these 2 seconds displacement, are you getting 40? See, 5 plus 15, is it 40? No, sir. If you add these two, are we getting 40? Yes, sir. Which means definitely our last 2 seconds will be second and third second. Then only their addition is going to give you 40 meters. All right. So conclusion is the total time of fall is only 3 seconds. Therefore, the height of the tower is half GT square. Half GT square for the total time of fall is 3 seconds. We are going to get the final answer as 45 meters. So no need to break the motion, no need to analyze the upper part of motion and lower part of motion separately. Rather, we could have directly applied the Galileo's problem as per the situation of the question. All right. So with this, I'm concluding today's session. Very soon in the next 10 minutes, you are going to have your chemistry session with Anirudh sir. The way we have beautifully understood the details and concepts of the Galileo's formula and a smarter way of using these techniques to solve the crucial problems. The same way, I'm sure you are going to learn a lot with Anirudh sir in chemistry track. All right. So take a small break. Come back soon. In the next 10 minutes, your session will start. All the best. See you soon tomorrow. Bye-bye.